Right, so we're carrying on with question 4. The peppered moth is found in many countries. So if you notice, it's light and that is dark. Right, the dark colored moth was first observed in cities when pollution from burning coal stained tree trunks black. Right, let's move over here. In 1992 to 1998, the number of light-colored moths went up, stabilized, dropped, and then went up again. Number of dark-colored moths dropped, and then went up, and then down, and up. So it fluctuated, but it's dropped from 27 to 9. That one's gone from 9 to 13. So this has gone up slightly overall, and this has gone down a lot. So that's the overall sort of thing that we notice straight away, yeah? Calculate the difference in percentage between the dark moths. So dark moths, 92, the percentage of dark moths in 98. So we're looking at dark moths. So there was 27 to 9. So what we do is so in 1992, 27 out of, if I add these two, 27 plus 9 is 36. So 27 out of 36 moths, turn it into percentage, you get 75%. So in 1992, 75% were dark. And now look at these two. No, let's do, right, so we do, if we add these two, 13 plus 9 is 22. So 22, 9 out of 22 times 100 is 41%. And it's saying work out the difference. So all we do is we do 75 minus 41, 34%. So it was a maths question more than anything else. Okay, let's keep moving on. Right. So we're going to do a graph, a line graph. And we're going to join it with straight lines. So we're going to go from 92 to 98. Let's have a look. If I did that as 1992, 1990, let me just check, 93 to 98, 1992, 1993, 1994. Okay, so we've done that, and we'll just put down here the year. Now we go up here, and what does it go from? It goes 27 to 1. The highest is 27. Can we squeeze that in here? Right, 2, 4, 6, 8, 10, 12, 14. No, we'll have to go in 2, so that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So we need to put of moths. So the what you put on here, you just type in number. This is weird, writing sideways. Number of moths. Okay, so now there's two types. There's okay. Right, let's try. See if this makes it easier. Just make a copy of that. Okay, let's crack on. Right, we'll do light colored moths. So we'll do it in red. Light moths. So that's the key there. It goes to 9. It goes to 11. 11, and then you go 5. You go 1. You go 8. And finally you go 13. Where's 13? That's 14. That's 13 there. Right, join them up with a ruler. Pretend that's a ruler. Pretend that's a ruler. Pretend that's a ruler. Oh, what a amazing ruler I've got. There you go, and there you go. Then what I'll try to do is go for, these are going to be dark moths, and it'll be 20. Right, let's move up. Right, 27, and it goes to 11. Then it, no, whoa. Right, 27, better keep my eye on this. 18, 7. 18, 7, 1, 4, 1. 1, 4, 1, and finally 9. That's 10, so that'll be 9. We use a ruler, 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 ruler. Right, there you go. Right, so now these questions are coming in now. They want you to think about stuff more yourself now. It's in comment on the changes. It doesn't say explain why do you think this happened, but that's interesting. So if you get a question like this, it says comment on the changes. You can throw in an explanation, because I first thought, okay, random mutation, less black moths, more black moths. So, but let's talk about the actual graph itself, or the data itself. Is visually it's easier to see. Look, you can see the dark colored moths drop to 95, and then it finishes at 9. So there's overall 3 times a drop over the years. The light colored moths go up slightly, level out, and then they drop to 96 and then increase to 98. So overall there's a slight increase from 9 to 13, and we've got to show that. Right, so this will be an interesting one. So we can say the number of light colored moths decreases, then increases. We can say the same thing about the number of dark colored moths decreases, then increases. Right, so we can make those statements. Then we can say overall the population of moths decreases. So we made all these statements. We can then continue making a statement. Right. Why do you think the overall populations decreased? This may be due to more predators. That's called predation. Or it could be due to disease. Right. We can make a statement such as overall the drop in dark moths was higher. So from what was it, a 27 to 9, whilst the light colored moths increased. Right, yeah, we can't say it was higher because that would make it so. No, we need to reword that. Yeah, that would make the overall the dark colored moths dropped in numbers, increased from what was it, 9 to 13, from right. Okay. Now, so we'll give an explanation. Right. The dark moths, dark colored moths were less camouflaged. They were less so were easier to spot by predators and were killed or eaten. Right. So the light colored moths bred and or mated and passed on the light colored moth genes to their offspring. Right, okay. It's a tough one, but these are coming in more and more where they're asking you to make something. So what I found interesting was it said comment, but there was nothing in there to suggest that explain. So that's one explanation. More predators. It could be due to disease or the fact that you're passing on the alleles over a short period, right? Okay, what's next? Chromosomes, karyotype. So this type of diagram is called a karyotype, where you're shown all the chromosomes in pairs. So that's one chromosome, that's another chromosome. So these are all from one from mom, one from dad. This looks like as if it's X, and that looks like as if it's Y or X. Right, so this type of diagram is called a karyotype, and we're looking at white blood cells. Chromosomes in white blood cells are larger. Right, there you go. So first question, explain why red blood cell cannot be used to show karyotype. Right, because remember, red blood cells have no nucleus, so it's a 2 marker, so no chromosomes present. Chromosomes. State the type of cell division that occurs in white blood cells. So white blood cells are body cells. So remember we said there's 2 types of cell division. Cell division. What did we say? Body cells and gametes, which are sex cells. Right, so you have body cells. It's, look, my toe is part of my body. So that's mitosis. And the other one would be meiosis. Meiosis. So this I remember it. My toe is part of my body. So white blood cells, I've got 46 chromosomes, so they divide by something called mitosis. Right. Karyotype in diagram is for a male. State how this can be deduced from the diagram. Right, because we can see that the last alleles or the last chromosomes are different in terms of size. So, and remember the egg cell or the ova is larger, or ovum, should I say? Ovum. And the sperm cell is smaller. And sperm cells are much, much smaller. So if you go up, we pointed this out over here. There. Right, okay, let's keep moving on. So you've got another chromosome. It's from a female. It's a condition that they've called Turner syndrome. Right. The condition affects the development of ovaries, so they may not produce normal quantities of sex hormones. So if you look, there's a chromosome missing here. There's one missing. Comment on the differences in the two. Right, the most obvious one is karyotype 1 has 46 chromosomes. Karyotype 2 has 45 chromosomes. And it seems to karyotype 2 lacks one of the sex chromosomes. And that's just looking at the last pair. Now, how do you know which one it is? It was saying, comment on the different types, right? So it's saying here, this condition affects the development of the ovaries, so may not produce normal quantities of sex chromosomes. So what that's saying is you're gonna lack the Y chromosome. XY. No, you lack the X chromosome actually. Right, so because of the problem with the ovaries, you're gonna end up with a chromosome type 2 will lack well, we don't it doesn't really know, but so we'll lack either Y or lack or have less of the X chromosomes. We don't know which one. I'm assuming because there's a problem with the where are we? I've said affects the development of ovaries. So I think it's gonna lack the X chromosome. I don't know if I'm allowed to make that assumptions. So what happens is the female or the woman or the girl will have problems with normal puberty. It could be loads of things. If you don't go through normal puberty, that means you're gonna have delayed secondary sexual characteristics. You're gonna have less, I suppose, what do you call them? The cycle, the menstrual cycle, less or irregular or menstrual cycles. It could cause that. What else would it be? You might produce less or eggs or no eggs, ovum. When you're trying to become pregnant, your uterus lining might not repair. You could have problems with these. You might even produce eggs with 23, just say 22 chromosomes. Yeah, instead of 23 chromosomes. It's hurting my brain. This is right. I think that's about it. Right, let's get this finished. Suggest how the difference in chromosomes of people with Turner syndromes may have been produced. have chromosomes, right? Okay, mutate. Normally, if there's a difference, if there's a difference in chromosomes, it's normally to do with random mutation, where one of the sex chromosomes did not replicate properly. Correctly. Right. So remember, you've got males have XY chromosomes and females have what do they have? Come on, XX chromosomes. And let's do the Punnett square. It's always good repeating this, so then it goes into your head. So the male, and this is the female. You've got X, X, and from the male you've got X, Y. So now if you, there you go, if you cross these two, you're going to end up with X, 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 X. This one's going to be X, Y. And again, if I did this gamete with this gamete, you're going to end up with XY. And this is why you end up with, you've got 50% chance of a girl, and well, that's not going to work, is it? 50% chance of a boy. Right, we'll call it quits here, but potato. Right, okay, we'll do this in the next video, inshallah.